Alright, welcome back. So we are continuing into Chapter 10, and this is Section 10.2, Personal Loans and Simple Interest. And so we are introduced to our simple interest formula, I equals P times R times T, where I is the interest that we're looking for. That's the money that's created from this investment. P is the principal. That's the starting amount of money. So like if you're putting money into a savings account, that would be your P, how much you're putting in, like $500 or so forth, okay? R is the interest rate per year, and of course that needs to be in decimal form, very important. It needs to be in decimal form. And then the T is the time the money is invested or borrowed, and that needs to be in years. Okay, very important. Alright, so there is a second part of this lesson, and that's down here in the bottom left corner, okay? This is method 2, which is the ordinary interest banker's rule, okay? So you're going to see some problems that may introduce the banker's rule, and I'll address those here as we hit them, okay? Notice that my formula stays basically the same, I equals P times R times T. However, my T is based on 360 days, okay? So this 360 days right here is my unit of time, and we're going to put the number of days over 360, and that will represent my unit of time, okay? So there's going to be a little bit of a difference between some of these problems, and I'm going to try to stress in this video here the importance of the difference between the two, okay? Alright, so let's move down here a little bit. So I have put a Julian date calendar in here as well. So that second method that we looked at there on the screen before, we are going to need to reference this Julian date calendar to find how many days have occurred between two given dates, like April 1st and August 12th. Okay, and so a Julian date calendar is the best way to do this because we can actually subtract them. Alright, so let me give you an example real quick before we jump into some examples, okay? So if I'm going from January 1st to September 9th, okay? Well, January 1st, that's day 1, and September 9th happens to be 251, okay? So by subtracting these, I can see that there's 250 days between these two dates, okay? Alright, so January 1st might not have been a fantastic date to start off with. I probably should have started off with like February 23rd or something like that, so that way you could really see them being subtracted. But 251 minus 1 is 250 days, okay? And we will come back to this because we will need this for some of our examples that we're doing in this video. Alright, let's move down here to example 1. Determine the simple interest, and the rate is an annual rate, and assume 360 days in a year, okay? Alright, so we are using that formula that we saw at the very beginning. Interest equals P times R times T, okay? And notice it does tell us right here that assume there's 360 days in a year, because notice my time here is not in years, it happens to be in days. Alright, so taking this formula, we're looking for interest, so interest equals principal of $512.11 times my rate. Now my rate needs to be in a decimal, okay, so that'd be 0.095 times, now this is very important, okay, our time usually needs to be represented in years, but this time it's in days, so it's 97 over, and notice they tell us in the question itself, right up here, it says assume 360 days in a year. And we all know there's 365, but since it's telling us that specifically, that's called the banker's rule, and they always use 360 instead of 365. Okay, so we have to put that 97 over 360. Okay, so now I'm going to go ahead and grab my calculator here. I'm going to go ahead and divide 97 by 360 first to get that answer. And I get 0.2694444. It looks like the 4 keeps repeating. Okay, so I'm going to take that decimal that I just read out and do that times 0.095 times $512.11. So my simple interest comes out to 13.10859.347. Now we are talking about money here, so I need to round that to 2 decimal places. Okay, so 2 decimal places right there. So it looks like my interest is going to be $13.11. And that is my answer. Okay, we're only looking for simple interest, so how much interest was earned on $512.11 over 97 days at 9.5% interest, the interest rate, and that happens to be $13.11. All right, example number 2. We use the simple interest formula this time to determine the missing value. Okay, so notice this time we are missing R. Okay, so we are missing R. So again, let's go ahead and set it up. I equals P times R times T. Okay, now this time they give us I. So this is $142.20 equals the principal of 1,975. Okay, so we know P. We don't know R, so I'm just going to plug that in kind of like a variable, R. But this time we have time that's in years. Okay, remember time has to be listed in years. The only time we need to worry about putting it over 360 is when we have it there in days. Alright, so what I'm going to go ahead and do is I'm going to go ahead and combine these two. So 1,975 times 4. 1,975 times 4. 7,900. So we have $142.20 equals 7,900 times R. Alright, so this is just good old algebra here. Okay? I'm going to divide both sides by 7,900. Okay? That's going to get rid of that 7,900 on that side. And we're going to get R equals, let me punch that in my calculator, $142.20 divided by 7,900 comes out to 0.018. Alright, now we can't leave it in that format right there. Now that's the format we want to use when we're using our formula. Okay, the I equals P times R times T. However, notice, back on example 1, your R here was a percentage. Alright, so right now this is a decimal. So we need to change this back to a percentage. So we got to move the decimal point over 2 times. So my interest rate is 1.8%. Alright, so be careful with that because you may see a problem or two that involves a missing value. When you have a missing value, you just have to work some simple algebra there to find the missing value there, okay? Alright, moving down to example 3 here. Okay? Here is where we're going to have to use the Julian date calendar, okay? A partial payment is made on the date indicated. Use the United States rule to determine the balance due on a note at the date of maturity. The effective date is the date the note was written. Assume the year is not a leap year. Okay? Very important because if it was a leap year, then we would have to include an extra day in there for February. Alright, so first off, we're going to calculate the interest up to this partial payment date. So I equals P times R times T. Okay, so I equals, we have 2,000 this time, times my rate, which needs to be a decimal, so 0.04 times, now this is where we have to use that Julian date calendar to figure out from April 1st to May 1st. Okay. Alright, so I'm going to be scrolling back and forth here. Okay. So again, if you need to pause your video, please do. April 1st to May 1st. April 1st right here. May 1st right here. Okay. So we have 121 minus 91 which looks like that's 30 days. Okay, so that's 30 days from April 1st to May 1st. So let's scroll down here. And so again, that's 30 days, so I have to put 30 over 360. There we go. Okay, so we need to calculate that interest all the way up to that partial payment date, okay? So again, in my calculator here, I'm going to go ahead and punch in 30 divided by 360 and get that decimal, okay? Multiply that by 0.04 and then multiply that times 2,000. And we get $6.67. $6.67, okay? All right, so that's the amount of interest that was put on this account or placed within this account between April 1st and May 1st, okay, before the payment was made. All right, let me zoom out just a hair there, give us some room. All right, so what I'm going to do is I'm going to go ahead and add this to the principal, okay, which is that $2,000, and we're going to get $2,006.67, okay. Now, this is how much is sitting in the account as of May 1st, okay. This is how much that's owed, because I think this is like a loan. All right, so a payment is made on May 1st of $1,000. All right, you slide this over a little bit more. We take 1,000 off that, and that means we still have 1,006.67. Okay, and that is still May 1st. Okay, because these transactions are all occurring up. You know, well, the interest was added from April 1st to May 1st. The payment was made on May 1st, okay, to still give me a balance as of May 1st of $1,006.67. Now, I need to calculate the maturity date, which it goes all the way to June 1st, okay, which means we have to calculate the interest again. So interest equals principal times rate times time. So interest equals, this time my principal is a little bit different, 1,006.67. My rate is still the same, it's still 4%, so 0.04. But my time this time is from May 1st to June 1st. All right, so we need to go back up here, May 1st to June 1st. Scroll over here, May 1st we already have highlighted. Let's go over here to June 1st, which is 152. So when you do 152 minus 121, and it looks like we get 31 days. All right, so my time is going to be 31 over 360. All right, so going back to my calculator here, I'm going to do 31 divided by 360 to get that decimal first. And I'm going to do that times 0.04 times $1,006.67. And let's see, we get an interest of, and I'm going to go ahead and round this to the nearest penny, $3.47. Now, my last step in this is to add this back to the amount at my partial payment on May 1st, okay? So I have to take this and add it to that interest, so 1,006.67 equals, this is the final step right here, so $3.47 plus 1,006.67, which gives me a grand total of $1,010.14. And that is my answer. So there's multiple steps here. You're going to have to use your simple interest formula twice. Okay, you have to use it once to get, your total leading up to your partial payment, then take your partial payment off, and then calculate your interest again from that amount to your maturity date. Okay, and then that's going to be your answer, okay, which is that $1,010.14. Okay, let's do this again. Example number 4. Partial payment is made on the date indicated. Use the United States rule to determine the balance due on the note at the date of maturity. The effective date is the date the note was written. Assume the year is not a leap year. Again, very important. Alright, so again, we have to calculate how much interest has been earned all the way up to that partial payment date. Okay, so interest equals P times R times T. Interest equals, my principal is $6,000. My rate is 0.03. Okay, again, change it to a decimal. And my time, now this is what we have to calculate, okay, from July 15th to December 30th. Okay, alright, so I'm just trying to pause a minute before I scroll up. July 15th to December 30th. July 15th, let me use a different color this time. Let's use purple. July 15th, looks like it's 196 to December 30th. Okay, so that's 364 minus 196. Alright. Doing this by hand. There we go. 168 days. Alright, I hope y'all remember what to put that over. 168 over what number? 360. That's right. 168 over 360. Okay, so let's calculate what that interest is. Again, I'm going to go ahead and take my calculator. I'm going to do 168 divided by 360. Gives you a repeating decimal, it looks like. I'm going to do that times 0.03 and then multiply that by 6,000. Oh, interesting. Looks like it comes out to $84. Alright, so that $84 is going to be added to this principal right here. Okay. So plus 6,000. Okay. To get my new total. 6,084. Okay. So this is how much is on the loan as of December 30th. But there happens to be also a $2,000 payment being made on December 30th. So that comes out to $4,084 after the partial payment on December 30th. Okay. Alright. We're about halfway there. Halfway there. Alright, so let me scroll this over a little bit more. So again, we have to take interest equals principal times rate times time. Interest equals, this time we have our principal is $4,084. Our rate is the same. I just happened to forget what it was. 3%. So 0.03. And my time's going to be a little bit different this time because it's going to be December 30th to February 1st. December 30th to February 1st. Now, we have to be a little careful there because we are going into a new year. Okay? December 30th to February 1st. Okay. Alright, so February 1st happens to be day number 32. Okay? But I can't forget there's still one more day left in the year. Okay? So you have to be really careful here. So that February, that's going to be 32 plus 1. We're not going to subtract 1 this time. Okay? We can't do 365 minus 32. Or, well, let's see, it's really what, December 30th? We can't do 364 minus 32 because then we'll get 332, okay? And there's really not 332 days between those, okay? Even if you count them out. If we start at December 30th and you put your pencil right there, okay, and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay, so you can actually prove it if you sit there and count them. And you probably heard me tapping, and I was tapping on the screen at the same time as I was counting those out. Okay, you can kind of see the little pin marks too there as I was counting them out. But it came out exactly to 33, even counting them individually. Okay, now that takes a little bit longer, but it's still effective. You can still figure out how many days have occurred between dates if you want to count them out like that. Okay, if they do happen to be in the same year, you can always subtract them. Okay, but if they overlap from one year to the next, that's where you have to be a little careful. I've had some teachers always tell me that to count the number of days in each year and then add those two. And that's basically what we did here, 32 plus 1. There was only 1 day left in the year after December 30th, and then there was 32 leading up to February 1st. Okay. All right, so getting back to the problem here. So we had that 4,084 times 0.03 times 33 over 360. Alright, so 33 divided by 360. Okay. I'm always going to go ahead and do that first. Go ahead and take care of that fraction. 33 divided by 360 gives me a long repeating decimal here. I'm going to do that times 0.03 and then do that times 4,084. And it looks like I get an interest of $11.23. Now, we only have one step left, which is to take that principal amount as of December 31st and add it to that $11.23. So $11.23 plus $4,084 gives me an answer of $4,095 and started right at 3, sorry. $4,095.23. There we go. That's exactly right. Alright, again, if you get stuck on anything in 10.1 or 10.2, please feel free to take screenshots and send it to me through email with IDK, and I will be more than happy to work and